And specifically, all of the low-mass stars, like our sun, will make planetary nebulas and leave behind white dwarfs. But what about those super high-mass stars? Those ones die by exploding at the end of their lives. They naturally have a supernova even with no other stars. Watch the other videos for how that happens. But when they explode, they can leave behind two kinds of dead stars. And what kind of dead star you get from a high-mass star just depends on how much material is left at the very end of everything. If it is less than 2 to 3 times the mass of the sun, you're going to get what's called a neutron star. There we go. And if what's left behind is bigger than 2 to 3 solar masses, you're going to get a black hole. Okay, I'm going to move that down a little bit. There we go. So the two kinds of dead stars that high-mass stars produce, and you would have seen me mention these in a previous video, are neutron stars and black holes. You get a neutron star if the amount of material is relatively small, and you get a black hole if the leftover material is relatively a large amount. Okay? So black holes are totally crazy. That's what we're going to talk about for most of the rest of this week. What I want to finish up today is I just want to explain what a neutron star is like, okay? And we'll get through this without too much time. So here we go. Neutron stars. What are they like? Well, they're basically like white dwarfs. They used to be the core of a star, so they're pretty small. And they're very, very hot. In fact, they're even hotter than white dwarfs are. So their color would probably be even more bluish white than a white dwarf. Now, what's their size going to be like? Well, remember, the maximum mass of white dwarfs is 1.4. And most of them are a lot less than that. So neutron stars can have even more gravity than a white dwarf has, okay? Neutron stars have more gravity, usually, than white dwarfs. And before the explosion ever happened, these cores were crushed beyond the point that electrons can hold. So those degenerate electrons, they don't work. They can't fight gravity in a neutron star. That doesn't cause the neutron star to explode, though, because it crushed beyond that point while it was still contained inside of the original star. So, here we go. What I'm getting at here is this. If the electrons can't fight back in a neutron star with their degenerate nature, and we have an even higher gravity on average than a white dwarf, what's going to happen to the size of the neutron star? Would we expect neutron stars to have a bigger size or a smaller size than a white dwarf? Remember, gravity is stronger here, and the electrons can't fight. So what's going to happen to the size of the neutron star? It will be smaller. That is correct, okay? Remember, I said that white dwarfs stop crushing around Earth size. So neutron stars are going to be much smaller than the Earth, even though they can contain up to 2 to 3 times the material of our entire sun. They're going to be much smaller than the size of the Earth. In fact, they're going to shrink down until they get to be about the size of a large city. So a typical neutron star is about the size of New York City, but it contains the same amount of mass as up to 2 to 3 times the mass of our sun. So what's the gravity gonna be like near the surface of a neutron star? What's the gravity gonna be like way up close on those things? High, low, what are we talking about? It's going to be super intense. Remember how ridiculous I said the gravity at the surface of the white dwarf was? Well, this is going to be more extreme because we have more material crushed into an even smaller place. So the gravity at the surface is going to be even higher. It's actually so high that what gravity will now do is it will take all of the electrons and crush them tighter than those grids could ever get. Now, looking back at the last couple of videos, the kind of stars that explode and make neutron stars were the high mass stars. And the reason they exploded, watch the last couple of videos, is because their core turned to iron. Gas iron, but still iron, which it could not fuse. So it seems like this neutron star would be made out of mostly iron. But it's not, because it turns out that this gravity is going to crush this neutron so tightly that every single one of its atoms will combine. It essentially becomes similar to a giant New York-sized single atom. One combined atom. So it's not made of any elements anymore, okay? It's not made of any specific kind of element. And here we go. That means we start with a giant ball of neutrons, protons, and electrons. But gravity's gonna crush it, and gravity's gonna crush it. And eventually, gravity will fully crush it to the point where the electrons will be forced to enter into the protons. And what is that going to do? What kind of charge does a proton have? Give me that real quick. What kind of charge does a proton have? Positive, negative, what? Positive. And an electron is negative, right? Our proton's positive, our electron's negative. If gravity takes these equal but opposite charges and combines them, how much charge will it have now? If it had an equal amount of positive and negative, if gravity combines those protons with those electrons, how much charge do we have now? None. So, if you take a proton and you combine it with an electron and that takes away the charge, what did we just turn that proton and electron into? What kind of particle has no charge? What did we turn it into? There's a hint over there. A neutron. So essentially what happens is that the gravity in the neutron star takes a bunch of protons, neutrons, and electrons, but then combines the protons and electrons to make neutrons. So what is almost the entire star going to be made out of? Don't overthink this. What's the almost the entire star going to be made out of in that case? Neutrons. Yes. The entire star, almost the entire star, is made out of neutrons. That's why we call it a neutron star. So a neutron star is just a giant ball of neutrons the size of New York City. But once it crushes to the size of New York City, it stops crushing. Was gravity satisfied? No. Nothing ever satisfies gravity. So that means that something else in the star must be fighting the gravity. But what's the only thing in the star? Neutrons. So what fights gravity in a neutron star? It's not the electrons. They're basically gone. What's fighting gravity in a neutron star? Don't overthink it. The neutrons do. It turns out neutrons also hate each other. Neutrons also get degenerate. So when you squeeze them tight enough together, neutrons will make a grid. And instead of it being called electron degeneracy pressure, it's just called neutron degeneracy pressure. So what fights gravity in a neutron star? Neutron degeneracy pressure. Yes. But neutrons don't hate each other as much as electrons. That's why you have to crush it down to the size of a city before they complain and fight the gravity, okay? Electrons really hate each other, so they'll start complaining once the thing crushes to Earth size in a white dwarf. Neutrons only hate each other a little bit, so they don't complain and want personal space until this thing is New York City sized. Okay. So, what will this thing be like? Well, neutron stars are super unique in that when you crush that much material down to the size of a city, then the surface, even though it's extremely hot, the surface will solidify. The surface of a neutron star is solid neutrons. And the inside is mostly liquid. Liquid neutrons. And as you get down towards the very center, it gets so hot and dense that we don't even fully understand what it's like down there. This is the only type of star that has a solid surface. Okay, it's the only type of star with a solid surface. So you could land on it and walk around. Would you want to do that? Would it be a good idea to land and walk around on a neutron star? No, that would be a terrible idea. Even if you could survive the intense heat, what would happen to you if you landed on this solid surface? What would happen to you? I mean, you're going to die, yes. But how are you going to die? Even if you could survive the heat, what's going to kill you? Gravity's going to happen to you. Gravity's going to kill you bad. Yeah, gravity's going to kill you bad. So remember that you could liquefy on around the surface of a white dwarf. If you land on this, not only would you would go beyond liquefying, you would actually turn into a puddle. And that puddle would spread out over tons of miles because you're going to be flattened to less than an atom thick. Your puddle will be less than an atom thick, and the gravity of the white dwarf will be high enough to take your electrons and crush it into your protons. So, what will your entire body turn into if you land on a neutron star? If all of your electrons get combined with all of your protons. Your entire body would turn into neutrons. And the floor would be made out of neutrons. You would be made out of neutrons. And the floor would be made out of neutrons. And you're less than an atom thick now. So you just became the floor. You joined the floor. And your neutrons are not special. So if somebody flew past the neutron star, there would be no evidence that you had ever existed. That's how completely you would join the floor. You would be part of that neutron star and identical to the material of the floor. So yeah, that's don't ever visit a neutron star.